In this video, we are solving a rational equation. It is a rational equation because we have rational expressions represented throughout the equation. Those are expressions that have fractions. When we start this problem, we need to figure out first what is our least common denominator. So first, let's consider all the denominators. We have x plus 2, we have 7, and we have 4x plus 8. What we want to do next is make sure that all of these denominators are completely factored. So this one is completely factored. That is the simplest form it can be in. Same with 7. But if we look at this one, we see that there is something in common between these two terms. And we want to go ahead and factor this expression. So this will factor into 4 times x plus 2. So our GCF is 4. If we divide each of these by 4, we get x plus 2. So what we really want to look at is this one and the factored form of this denominator. Now, to find the LCD, what I usually do is just do it very methodically. Let's start with the first denominator. We're going to write that down as part of our LCDs, and we're going to put it in parentheses. So x plus 2, we're going to use that x plus 2. Now, what I want you to do is go through the other denominators and go ahead and check off any other x plus 2's that you see. Now, if they show up twice in the same denominator, you can only check it off one time. Okay, but it shows up once there, so we're going to say that that one's used. Now I want you to go through and just go ahead and include anything else that has not been included so far in the LCD. So we have a 7 that needs to be included, and we have a 4 that needs to be included. And we're going to multiply these together. So our LCD is going to be 28 times x plus 2. All right, now that we've decided what our LCD is, we want to, there's a couple different ways that we could do this. We're first going to do it, this method is going to be rewriting these expressions or these terms to have a common denominator. All right, so let's say we have 5 over x plus 2. And I want a common denominator here. So I want this LCD to be the denominator for all of these things that I'm about to do. This current term has x plus 2 in it. So my question would be, what would I need to multiply this x plus 2 by to get our LCD of 28 times x plus 2? And you can see it already has an x plus 2, but I really need this 28. So I'm going to multiply by 28. And if I do that on the bottom, I need to do it on the top. Okay? Let's go to the next term. So minus 3 over 7. And now we're thinking to ourselves, what does this need? It already has a 7. What do I need to multiply that 7 by in order to get this 28 times x plus 2. Sometimes it's easier to look at the factored form of this LCD. So if it already has the 7, it's missing the 4 times x plus 2. So this 4 times x plus 2 is what I'm going to put in the denominator. And if I put it in the denominator, I have to do the same thing in the numerator. And this is essentially multiplying by a factor of 1. So we're not really changing the equation. We're just putting it in a different format that's still equivalent, just to help us see it and maybe work it better. All right, this one is 6 over, and to help us out, we're going to write this in the factored form. So remember, the factored form was 4 times x plus 2. And what does this need? It already has the 4, and it already has the x plus 2, so it needs the 7 in order to have the LCD. So we're going to multiply 7 here and here. Now, the reason why I like doing it this way is because our next step is to get rid of the fractions. So we've got all these fractions, and nobody really likes working with fractions. That's okay. That's why we're doing this. because we want to eliminate those fractions. So I'm going to multiply all of this by our LCD, 28 times x plus 2. Now, remember that if you take something and you put it in the outside of a big parentheses, it's essentially distributive property. That's what it is. So if I say 28 times x plus 2 times this first set of expressions, what happens? Well, this 28 cancels and the x plus 2 cancels. That would be the same thing here. This is 28 x plus 2. Those are going to cancel. And 4 times 7 is going to be 28 x plus 2. So essentially what happens is that this LCD that you multiplied is going to now cancel with all of these denominators. And we like that because then it's getting rid of our fractions, and now we maybe have something that's a little easier to work with. So let's see what we get here. We're going to multiply the top. So 5 times 28 is going to give us 140 minus 3 times 4 is just 12. We're going to bring down this x plus 2. And then 6 times 7 is 42. Now you see we're left with a linear equation. So this is a lot easier to work, and we've worked with these before. So let's distribute. So this will be negative 12x, and this will be negative 24 equals 42. Now we're going to add like terms. So 140 minus 24 is 116 minus 12x equals 42. And it doesn't really matter the order there. You can put it however you want. And now we're going to, are we adding? No, we're going to subtract 116 from both sides. We get negative 12x equals negative 74. And last step would be divide. Divide by negative 12. So we get x equals, and let's simplify this, 37 over 6. So that ends up being my answer. Now I do want to say this is a rational equation. So this is a rational equation. And we need to remember one of those really important rules of mathematics, which is if it is a fraction, you cannot have a 0 in the denominator of that fraction. Now this is pretty easy to check with this. What you want to do is take this solution that you got, which in our case was 37 over 6, and plug it into your LCD. So over here we have 28 times x plus 2. If x is 37 over 6, the big question is this going to give me, is this going to equal 0? Does it equal 0? No, it doesn't. So this would have to be 0 in here, and 37 over 6 plus 2 is not going to equal 0. It doesn't really matter about the value of what that would be, but the biggest thing is this cannot be 0 because we got all of these values, this least common denominator, from the denominators. So if I plug in this x and it gives me a 0, that means that one of these denominators would be 0. And then I would have an undefined value. And that would mean this would not be a solution of the equation. Okay? So this is our answer. This 37 over 6 is our answer because it does not make any of the denominators in this rational equation 0. So that's one way that you can work a rational equation.